Suppose if f is equal to r vector by r cube, where here r is nothing but xi plus yj plus zk. Similarly, r vector, this is r vector, and since r is equal to modulus of r vector, and this is nothing but root of x square plus y square plus z square. So this is the value of this. Okay. Now we need to check this one as whether it is solenoidal. That means whether it is del dot f equal to 0 or del cross f equal to 0. Okay, we need to check this. Okay, so how many of you got first one and how many of you got second one?
Second one, sir.
Second one.
Second one. What about first one? Have you tried?
Yes, sir.
But you should get 0, right? So in your class, most of the people have posted for this del cross f. Okay. So this one no one has did. Actually, it is both. So it will satisfy both the things. So how means, let us see. I think you got this, but I will try this. Here dou by del is nothing but dou by dou x I plus dou by dou y j plus dou by dou z k. You need to do the dot product between f. Okay, so first let us define what is f here. Okay, so left hand side I'll define. Here f is nothing but r is xi plus yj plus zk divided by r cube. So you have to write this one as x by r cube I plus y by r cube j plus z by r cube k. Okay, so do the dot product of this vector. So that means x by r cube I plus y by r cube j plus z by r cube k. Okay, so this one is equal to dou by dou x of x by r cube ijk one comes since you are doing dot product, dou by dou y of y by r cube plus dou by dou z of z by r cube. So this is nothing but you need to differentiate this. Okay, so for my convenience I am writing this one as dou by dou x of x into r power minus 3. Shall I? Dou by dou y of y into r power minus 3. Similarly, dou by dou z of z into r power minus 3. Okay. So, but what is r here? R is nothing but it's a scalar function which is consists of x, y, z. Okay. Similarly, x is also a function of x. So when both are the functions of x, so we have to apply product rule between these two. Okay. So first I will apply this dou by dou x of r power minus 3 plus r power minus 3 dou by dou x of x. So this is for the first term plus y into dou by dou y of r power minus 3 plus r power minus 3 into dou by dou y of y plus z into dou by dou z of r power minus 3 plus r power minus 3 dou by dou z of z. Correct. So this one equal to, just simplify this, how much you'll get? X into differentiation of r power n. So this is nothing but n into r power n minus 1. So minus 3 minus 1, you'll get minus 4. Plus here r power minus 3 will be there. Plus y into minus 3 r power. But here one more thing you have to remember. Whenever you have differentiated function of x, so since r is multiplicable function, so you have to write dou r by dou x. I think most of the people didn't wrote this. Okay, so minus 3 r power minus 4 into dou r by dou x will come. Similarly, r power minus 4 dou r by dou y will come, plus r power minus 3 plus z into minus 3 r power minus 4 dou r by dou z. Okay, plus r power minus 3. So if you do that, what happens? Total 3 r power minus 3 values are there. Next plus in all these second terms or first terms. So minus 3 r power minus 4 is common. So I have taken that common. So whatever remains, I will write it. X into dou r by dou x plus y into dou r by dou y plus z into dou r by dou z. Okay, so this one is equal to 3 r power minus 3 minus 3 r power minus 4 into, so here what happens, x into this can be written as x by r plus y into y by r plus z into z by r. Okay, so this one is equal to how much? 3 r power minus 3 minus 3 r power minus 4 into x square plus y square plus z square divided by r. So this is nothing but 3 r power minus 3 minus 3 r power minus 4 into, what is this actually? If you take square on both sides, so you'll get r square here, r square by r. So 1 r get cancelled. So what happens? Here I'll write, this one is equal to 3 r power minus 3 minus 3 r power minus 4 plus 1. So when bases are same, power should be added, right? So r power minus 4 into r is there. So I have to write plus 1. So what happens? 3 r power minus 3 minus 3 r power minus 3. So these two get cancelled, you'll get 0. Fine. So this value is both solenoidal as well as irrotational. Next, till now we have discussed about vector differentiation. Okay, so we have integration for that also. Okay, integration for vector variables. Okay, vector functions. So let us see how to do this. Okay. Here they have given a curve C in the space. Okay, which consists of infinitesimal small length elements of length dr. Okay, dr is the smallest length of the curve. Okay, then the line integral of vector A, where A is a function of x, y, z. Okay, along the curve C is defined to be the sum of scalar product of A and dr, and it's represented by integration of A dot dr. Okay, so in this way we will do the integration by doing the dot product between A vector and dr. Okay, where here dr is defined like this. As we are taking usually r vector is nothing but xi plus yj plus yj zk. Okay, so if you differentiate with respect to dt, what happens? So differentiate this one with respect to t partially. So what happens partially, or this dr by dt, if I do, what happens? So dx by dt you will get I, plus dy by dt you will get j, plus dz by dt you will get k. So here you have to remember that x is a function of t, y is a function of t, and z is a function of t. So then only you can able to differentiate like this. Okay. If this is not a function of t, then what happens? What happened to derivative?
0.
So directly you will put 0. Okay. So that thing you have to remember. So whenever x, y, z are the functions of t, then only we can able to write like this. Okay. So this one can also be written as dx is equal to dxi plus dr equal to dxi plus dyj plus dzk. So dt on both sides I have cancelled it. So you can write the dr as like this also. Okay, this is one representation of giving dr. Okay, this is the dr value. Small difference in r. So small difference in r means difference in x way, that means a difference in x axis, difference in y axis, difference in z axis. So all together will give difference in r. Clear? So now we are taking the difference in r to dot product of function of a, that means function vector a. So where a is defined as a1i plus a2j plus a3k, where a1, a2, a3 are functions of x, y, z. Okay, so then you'll do the dot product between these two and we'll do integration for that. Clear? So now here this integration can also be denoted in by using separate word, that is called total work done. So whenever he asked us to find line integral or single integration, he will ask us in this way: find the total work done by the given force. Where here r is nothing but this one. Okay, f is nothing but this a vector. Yeah. So you have to do the dot product between these two and you have to evaluate the integral. That's it. Yeah. So let us see how does the problems will be there. Here we have a question in this way. So let us solve this. So given f vector is equal to xy I plus yz j plus zx k. Okay, and he is asking us to evaluate integral of f dot dr, where c is a curve representing by x equal to t, y equal to t square, z is equal to t cube. Okay, so implies He has given x is equal to t, y equal to t square, and z is equal to t cube. Okay, so that means whenever they have given this kind of questions, okay, what you need to do, convert this f function in terms of t, because x and y, z are the functions of t. So convert f also in functions of t. So f is equal to t into t square. So I'll get t cube I plus y into z. Y into z means t square into t power 3. So that means t power 5j plus zx. Zx is nothing but t cube into t. So you'll get t power 4k. So t power 4k. So this is the function of x, so on. So this is the function f in terms of t. Okay. Similarly, I need to find what is dr value. So how will I find dr value is nothing but first I will define r. R is nothing but xi plus yj plus zk. Substitute this variable, x is equal to t, so that means ti plus 2tj plus 3t square k. Okay, differentiate with respect to t. So if you differentiate with respect to t, what happens? Dr by dt is equal to, so differentiation of t with respect to t, it is 1i plus 2, sorry, here this is t square j t cube k. Okay, so 2tj plus 3t square k. If you differentiate t, t square and t cube, you will get these values. Fine. So it implies dr value will be equal to, send this dt to that side. So I plus 2ty, sorry, 2tj plus 3t square k into dt. Okay, now your dr is ready and f value is also ready. Now what we need to do? Integration of f dot dr. Okay, so implies, and you may get one more doubt, what will be the limits? So the limits he has given as -1 less than t less than 1. So take integration around the curve C, f dot dr is equal to, limits they have given it as -1 to 1, f value is t cube I plus t power 5j plus t power 4k dot, here dr value is nothing but I plus 2tj plus 3t square k into dt. So this one is equal to, do the dot product, integral -1 to 1, t cube into 1, so I'll get t cube. Okay, t power 5 into 2, 2t, so that means 2t power 6j plus 3 t power 5, sorry, t power 6 k. Sorry, this, since we are doing dot product, you'll get like this, 3t square t power 6 dt is equal to, so integration is with respect to dt. So what happens? T power 4 by 4 plus here 2 into t power 7 by 7 plus 3 into t power 7 by 7. Limits are from -1 to 1. So this is nothing but t power 4 by 4 plus 2 plus 3, it is 5. T power 7 by 7 minus 1 to 1. Okay. So just apply the limits. How much you'll get? So this one is equal to 1 by 4 plus 5 by 7 if I apply upper limit minus of here 1 by 4 p power that means minus 1 power 7 where 7 is an odd number. So I'll get minus 5 by 7 will get. So this is nothing but plus 1 by 4 minus 1 by 4 get cancelled. Minus of minus will get plus 5 by 7 plus 5 by 7. So total will get 10 by 7. So which is the answer for your integral f dot dr over a given curve C. Okay. So just go through it once again. If you get any doubts, check once. Fine.
Sir, can you show the previous slide?
Is that okay? Okay, we'll move for next one. Okay, we'll try this. So given f vector is equal to, he has given it as 3x square plus 6y into I minus 14yz into j plus 20xz square k. Okay, now we need to evaluate f dot dr, but r value he didn't give directly, but he has given x is equal to t, y equal to t square, z is equal to tq. Okay, so implies convert f in terms of t. So f is equal to 3t square plus 6t square into I minus 14 into yz. Yz is nothing but t square into tq. t power 5 j plus 20 x z square. Z square is nothing but t cube whole square. So 3 into 2, it is 6. So t power 6 into t. So total t power 7 k. Okay. So finally f vector can be written as total 9 t power 2 I minus 14 t power 5 j plus 20 t power 7 k. So take it as equation 1. Now I will define what is R. R is nothing but xi plus yj plus zk. So which is nothing but ti plus t square j plus t cube k. So implies if you differentiate with respect to t, dr by dt is nothing but how much? So I'll get 1i plus t square j, that means differentiation of t square is 2tj plus 3t square k. Okay, so which is nothing but dr is equal to how much? I plus 2tj plus 3t square k into dt. So implies what I will do is f dot dr I will find now itself. So what happens? F is from first equation, this is from second equation, this from 1 and 2. So 9t square minus 9t square I minus 14t power 5j plus 20t power 7k dot product of I plus 2tj plus 3t square k dt. So this one is equal to how much you'll get? 9t square minus 28 t power 6 j plus 60 t power 10 k. So this is the dot product value. Now implies integral
Sir, 60 t power 9, sir.
T to the power 9.
okay. T power 9. So we'll get t power 9. So integral of f dot dr c is equal to integral 9t square minus 28t power 6j. Sorry, j won't come here. Here also won't come because we have did dot product. Okay, 28t power 6 plus 60 t power 9. After doing dot product, check that whether you have written ijk or not. Ijk should not come in the middle. Okay. So into dt. But what are the limits? Limits for t, how will you find? Here they have given 0, 0, 0 to 1, 1, 1. Okay, that means x value varies from 0 to 1, y value varies from 0 to 1, z value varies from 0 to 1. Okay, substitute all zeros, that means x, y, z. What happens? T value also will get 0 every time. Similarly, substitute x equal to 1, y equal to 1, z equal to 1 in these equations. So what happens? T equal to 1, t square equal to 1 implies t equal to root 1. Okay, root 1 is 1 again. So next again 1 equal to t cube will get. T is equal to cube root of 1. Cube root of 1 it's also 1. So when x equal to 0, y equal to 0, z equal to 0, t value is also 0. That means lower limit is 0. When x, y, z are equal to 0, you got again t value also 1. So that means upper limit is 1. So integral 0 to 1 you have to write. So this one is equal to 9 t cube by 3 minus 28 t power 7 by 7 plus 60 t power 10 by 10, where the limits are from 0 to 1. So 3 ones, 3 threes get cancelled, 7 ones, 7 fours, 10 ones, 10 6. So I'll get 3. If you substitute t value as 1, 1 cube is 1. So minus 4 into 1 it is 4 plus 6. Minus 0 plus 0. So this one is equal to 3 plus 6, 9. So 9 minus 4, it is 5. So the integral value f dot dr over the given curve C is 5. Clear? Any doubts?
So those limits, can you?
Limits, he has given x equal to t, y equal to t square, z equal to t cube. Okay. In the first point, what they have given 0, 0, 0. That means these are x values. So take x equal to 0, y equal to 0, z equal to 0. Implies if you put 0, 0, 0 here, what happens? T equal to is also 0. Correct. Similarly, x equal to 1, y equal to 1, z equal to 1. What happens? 1 equal to t you will get. Similarly, 1 equal to t square will get. 1 equal to t cube will get. Okay. So implies t equal to 1 here. T square equal to 1 means t is equal to root 1. Root 1 is 1. Similarly, t is equal to cube root of 1. So this is nothing but again 1. So when x equal to 1, y equal to 1, z equal to 1, we got t value also all times 1. Okay. In case if x, y, z are getting different values for t, so then we can't find limits for t. So x, y, z should have same kind of limits. Then only we can apply the limits for t. So here for x, y and z, all are having same limits for t. So I have considered t value upper limit as 1 and lower limit as 0. Clear? Is it fine? Is any doubts?